In this video, I'm going to prove each trig identity. So I'm going to have an equation that tells me these two sides are equal, and I need to show that they're equal. I'm always going to take the more complicated side and rewrite that one, and just keep rewriting that one until it looks like the other side. For number 7, I am going to rewrite this side because it's more complicated. And first thing I'm going to do is I'm going to rewrite this. So it's cosecant of x plus secant of x divided by sine of x plus cosine of x. I'm going to rewrite cosecant of x plus secant of x as fractions so that I can combine the two terms. So I'm going to write it as 1 over sine of x plus 1 over cosine of x divided by sine of x plus cosine of x. So I'm going to put this in parentheses so I don't get messed up, and this in parentheses so I don't get messed up. And then from there, I am going to combine these two fractions, and I'm going to write this as, but in order to be able to do that, I need the same LCD. Sine and cosine don't have anything, like I can't multiply one by something to get the other, so I'm going to have to multiply them together to get the LCD. So I'll have the LCD is sine of x times cosine of x, which would mean this would be cosine of x over sine of x cosine of x, plus this would be sine of x over sine of x cosine of x. And that I'm going to change this division to multiplication and change this to its reciprocal, which would be 1 over sine of x plus cosine of x. And then I can combine these two things. So I'd have cosine of x plus sine of x all over sine of x cosine of x times 1 over sine of x plus cosine of x. And then I'm going to see that this and this cancel, and I'll have 1 over sine of x cosine of x. And the goal is to get it to be this, so I'm going to have to think of some way that I would be able to separate these two things. X. In order for me to be able to separate this fraction, I'm going to need to have two things in the numerator. So I'm going to actually go backwards from what I would normally do and use a trig identity that I know is equal to 1 that has sine and cosine. So I'm going to use that first, that trig identity that is cosine squared of x plus sine squared of x is equal to 1. And I'm going to rewrite the 1 as cosine squared of x plus sine squared of x so that I have two terms in the numerator so I could separate this. So I'm going to have cosine squared of x plus sine squared of x all over sine of x cosine of x. And if I do that, I'm going to be able to separate this into two fractions, cosine squared of x over sine of x cosine of x plus sine squared of x over sine of x cosine of x. And then from there, I can see that a cosine of x will cancel in the top and the bottom here, and a sine of x will cancel here, and I'll be left with cosine of x over sine of x plus sine of x over cosine of x. This here is cotangent of x, and this here is tangent of x, and that is what I had on the other side. So I'm done with that one. For number 8, I see cosine to the 4th power of x minus sine to the 4th power of x equals cosine of 2x. On the left-hand side here, I see that's the difference of two squares. It's cosine squared of x squared minus sine squared of x squared. And so I can rewrite it. Like the first thing that I want to do when I see the difference of two squares is I want to factor. So I'm going to factor this to be cosine squared of x plus sine squared of x times cosine squared of x minus sine squared of x. And then this here, I know I can rewrite as just 1 using a Pythagorean identity, and this one here, I know I can rewrite as using another identity, cosine of 2x, and so when I multiply those two together, I get cosine of 2x, which is what I have here, and so I am done. For number 9, I want to rewrite the left-hand side because it's more complicated. And I want a common denominator so I can combine those two fractions. So I need to look at what's the LCD. I can't multiply one by something to get the other, so I'm going to have to multiply them together. Sine of x plus 1 times 1 minus sine of x, and see what I get. So this would be sine of x minus sine squared of x plus 1. Ooh, that looks weird. Oh, plus 1 minus sine of x. This is going to cancel and this is going to cancel, and I'm going to be left with 1 minus sine squared of x. So that's what's going to be the new denominator, which we can use a trig function to change later on. I'm going to end up with 1 over sine of x plus 1 times the LCD, or times what I need to 1 minus sine of x, 1 minus sine of x. And then I'm going to multiply the second fraction by the other denominator. So this is sine of x plus 1 over sine of x plus 1. Giant 1 doesn't change the value of that fraction. And then I end up with, this is 1 minus sine of x all over, it'll be 1 minus sine squared of x, plus sine of x plus 1 all over 1 minus sine squared of x. And then when I combine the two numerators, these are going to cancel, and I'm going to be left with 2 in the numerator over 1 minus sine squared of x. 1 minus sine squared of x, I know if I see 1 and sine squared of x together, then I can use the trig identity cosine squared of x plus sine squared of x is equal to 1. Get it to look like that. Subtract sine squared of x on both sides. And I know I'll be replacing 1 minus sine squared of x with cosine squared of x. So this is 2 over cosine squared of x, which is 2 times secant squared of x, because this is the same as 2 times 1 over cosine squared of x. And I can replace this with this. And then that is what I have on the other side. So I'm done.